Today, I'm going to focus on the deepfake threats and detection. So basically, what kind of threats posted by deepfake and how do we detect them? So what is deepfake? So from Wikipedia, deepfake is defined as a synthetic media in which a person in an existing image or video is replaced by someone else's likeness. So here's an example of this.
This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. It's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward in the age of information is going to be the difference between whether we survive or whether we become some kind of fucked up dystopia. Thank you.
Yeah, this is a very brief example of the most commonly appeared deepfake, like the face swap and face manipulations. So, however, I would like to introduce a more broader definition. So the broader definition is like any content that is generated or manipulated by deep learning techniques are deepfakes. So the different techniques can be GANs or other deep learning models like a face swap neural network. And the content includes but not limited to videos, images, speech, and text. Here, I just would like to give you a few more examples in the broader definition. So here on the left-hand side, you can see like the top video is the original video with a Spider-Man mask. And in the lower video, you can see like the character actually totally removed just by a deep learning model called Deep Flow Video Imprinting. And there are quite a few deep video imprinting models, you can freely download from GitHub. And we have experimented with that, and they are very effective. And here's another example, like one can just change the semantic of a video by a GAN model. For example, this the road they changed from like the texture of the road they changed by a cycle GAN. And this is like pretty easy. Sorry. The third example is there are complex of GAN models that generate fake images, and these fake images are very realistic. So, for example, there are a few examples of like big GAN generated images, and they looks pretty natural. So, the question is why deepfake matters. So, why they pose a threat? So, previously, modifying or generating content requires strong domain expertise. Like, for example, like these Hollywood movies with CGI. So you need experts in computer graphics to do these movies, and they do a very good movie like for months of work with a big team. However, the deep learning techniques like substantially decrease the barrier to produce realistic fake content. And for example, the deepfake techniques, take GAN as an example, evolves very fast. As you can see from the graph in the top right corner, the face generated by GAN in 2014 is like a black-white image with only the face cropped, and it looks not so sharp. But just after 4 years, like the face is almost to me, it's almost indistinguishable from a real human face. And another thing is that the computation cost keeps decreasing, and the computation power is keeps increasing. So to train a deepfake model becomes easier and easier, and then run a pre-trained model is even easier. Like if you can just download some pre-trained model from GitHub and then you just run on your computer. You don't even need a GPU actually. And to use these models, it requires a minimal human inputs using these well-trained models. You just have the model running and have your input ready, and then put your input, go through the model, then you have the output. You don't have to edit frame by frame for a video. So this reduces a lot of human effort. So to give you a few examples, so when I Google deepfake video makers, I can see like there are quite a few online apps that allow you to just do deepfake videos. And you can see there's also a video tutorial how to do that. And if I search like object removal, like the one that I showed you, like the deep imprinting, you can find these are free apps online, and like some of them are charged, but most of them are free. So you can use that. I actually use some of them, and they are really effective. And if you search like deepfake speech synthesis, and there are like online services that allow you to do that. And there are also like video tutorials. So that means like these deepfake techniques are really accessible to like any human. So it's substantially lower the barrier for this for creating realistic fake content. Not to mention, like there are like a lot of YouTube tutorials. You can just follow the YouTube tutorial. I actually follow some of them, and it's really easy to run a model and generate fake content by you. And George already showed you like he has a code, and you can just borrow, and it's really easy. And if you want to just say, I want to state-of-the-art models, then you can just go to some GitHub repos. And it's free, and you can download them and just run on your computer. Like for example, this face swap, deepfake, deep face lab, you can just download it, and you can see the paper is published last year. It's like free, pretty state-of-the-art technologies. And also, like for example, the voice deepfake, like basically deepfake someone's voice, someone's speech. You can download the repo from like GitHub. And it's pretty good. So usually when the first time I know deepfake, because there's a fake word inside this word, so I always associate it with something bad. Like for example, like in the social media, someone create fake content, make a disinformation or something like that. But if we change the word, like change the deepfake into AI-generated synthetic media, this sounds much more empowering. And George has already showed quite a few examples, like how to use a deepfake for good. So I just gave you a few more examples. Like for example, the first one is for the voice deepfake rather than the image or videos. This is just for the voice, the audio content. Someone consider to use a voice deepfake to assist these verbal impaired children to speak naturally. This is very encouraging application to me. So this enhances the quality of life for the children. Another example is like you can use GAN, like some GAN can restore like old photos into make it better. And also coloring these old white and black and white photos into make it looks more vivid. So it's pretty good. And this is an interesting one. So there's an Indian politician used deepfake to win new voters. He recorded a speech in English, like record a video speech in English, and then he make a second video using deepfake languages so that his mouth moves convincingly as he speaks in Hindi. So then he just use that video and to win the votes from the Hindi speakers. So it's pretty cool, but it's also caused some controversial. So another cool application I just found recently, it's not recently, like half a year ago, so the NVIDIA, they use a GAN to do video conference, like video meetings. And this technology significantly lower the internet traffic for video meetings. So what they do is they only just send one or maybe two photos of the person to meet from one end to the other end. And then afterward, they just track the face impression. not the whole image, but just a face impression, and then transmit the face impression from one end to the other end, and then use a GAN model to reconstruct the face impression based on the first image and also the face impression data. And this like significantly lower the internet traffic for video meeting. So these are all good applications. But also, like, if we think of fake, so it's of course sometimes like it poses a lot of stress, right? So the first thing would be like fraud, and that's a famous case for the voice deepfake. So a voice deepfake was used to scam a CEO out of like about like $200,000. So that's pretty amazing. Like, so basically the fraudster make a phone call to a CEO, and through the phone call, he uses a voice deepfake to make him sound like his the CEO's business partner, and earn the trust from the CEO and ask the CEO to transfer money to his account. And he succeeded in that. So another thing is like deepfake porn, like when like basically how the deepfake word first started is and deepfake porn is like has a lot of bad impact for women's life, and that kind of like they try to scam women and make by using these deepfake porn video or something like that. So another threat is influence operation by social media disinformation. So for example, like US always say Russia has try to use social media to influence US elections. So deepfake can actually be used for that. Like they create some fake videos for Trump to speak something, or for like Biden to speak something, and then just spread it in social media. And that can like change someone's mind to for voting. So that's pretty serious actually. I'm not sure it's really happened, but here's like FBI notification. I just in March this year they posted this white paper, and they particularly mentioned the deepfake used for like influence operations. So the third and fourth thing are pretty similar, but in just in different fields. The third is like a video forgery in surveillance cameras. The fourth is image and video manipulation in defense. So you know, like in defense, we have the UAV cameras to collect information for like the enemy's military base. So, but deepfake can just forge these images. For example, if you look at this image from a military base, do you see something strange? I give you like 10 seconds. Do you see something strange? You can post it in the chat. Okay, so let me give you the answer. So if you look at just the image on the left, you can see that the aircraft are just being removed. Actually, I didn't use a very advanced model. I like in my previous project, we use a state-of-the-art model. But here, I just use an online app. Like I just Google like object removal, and I just use that, and it gives me the result instantaneously. So yeah, it's like it looks pretty amazing. Like if you look at details, you can probably see something, but otherwise, it's pretty hard to spot the manipulations. So how do we deal with the threats? So the first thing is, of course, we want to have a more secure system. So it's harder for people to hack, and then to do the man in the middle manipulations or forgery. The second layer would be like add certain marks to authentic contents. As Bio have mentioned, like they try to do authenticity for certain like certain images or something like that. So there's an example like watermarking by neural network. So if a content is forged, then the watermark will be damaged, and then you can easily detect that damaged watermark. instead of just try to detect from purely the image. So there are a few papers on like deep image watermarking or deep speech watermarking. Also, like the third layer would be like kind of the last layer is a deepfake detection. So a layer on top of the data security and the authenticity systems. So I pretty much worked on deepfake image and video detection. I cannot release much details about my work, but I just give you like from the public literature what people are doing this, how people are doing this. So to do like image deepfake detection, like image and videos they are pretty similar. Video is just a collection of images, and they are coherent in time, right? So any image method, image deepfake detection method can apply to video, and you can add a time dimension to that to make it a little bit more accurate. So to do image deepfake detection, we consider the image integrity. Here is some content I basically duplicated from Dr. Turk from DARPA. So the first is digital integrity. So if you look at this GAN-generated face and zoom in to the digital details, there's a trackboard pattern associated with it. And if we do a full transformation, we see the black peaks, like the peaks out of like away from the center. So that indicates as like some periodic patterns. So the digital integrity, we look at more like the digital level, the pixel level information. And another is physical integrity. Basically, things have to obey physical rules, right? Physical laws. For example, in this image, if we look at the shadow, all the shadow should come from one light source. But there's one that comes from a different light source. There's this person in the like up front. And that means that person is added afterwards. The third one is a semantic integrity. So basically, the semantic information in an image have to match some other data source. For example, in this image, it shows like it's a rainy weather it's actually downtown Vancouver. But if the weather record at the same time because it's sunny, there must be something wrong here. It's either the image or either the weather record have something wrong. So that's a semantic integrity. So for the deepfake detection solutions, most research have focused on digital integrity. Then the problem becomes simple, like it's a binary classification problem. It's either real or fake. And the data set basically constructed from like authentic images and videos, plus deepfake generated or manipulated images and videos. And then you have a data set with positive and negative samples. So there are like basic two classes of detection methods. The first one is image-based model. So because we do image detection, right? So we can image classification. We can just use a RGB image as an input for a convolutional neural network and do the classification. So that gives like about 95% detection accuracy on a cyclogram data set. Another method, another avenue is a texture-based model. So basically take advantages of the image texture information. So the first kind of texture would be the coherence matrices. And you can see there are a few papers on this using coherence matrices, and they achieve like 99% detection accuracy on a collection of GAN data sets. Another texture information is a Fourier transformation I showed you before. And it's also achieved like larger than 99% detection accuracy on like a cyclogram data set. So why the texture information is so effective for deepfake detection? Let's revisit the GAN architecture. So in the GAN architecture, like Bewu have introduced, so there's a generator and there's a discriminator. And then if you look at the generator, there's like from the random noise that goes through a lot of convolutional layers. So these convolutional operations, if you see like, it's always repeat. It's convolute, right? So it's repeat to convolute from previous layer to generate the information of the last layer, like the next layer. So these repeat operation usually tend to give some like certain patterns that different from natural images. That's why, for example, in this kind of like cyclogram models, you can see the trackball patterns. So nowadays, like the style gun or something like that, it becomes like the trackball pattern is less obvious, but this still creates some particular patterns, and it's pretty effective to use this pattern to detect these GAN-generated images. So there are two texture-based models. One uses coherence matrices, and you can see like the basic idea is like convert an image into coherence matrices. The idea of coherence matrices is just measuring like how many times a pair of neighboring pixels happens. The neighboring pixel, for example, like a pixel value of 1 and pixel value of 0, how many of this pair happened in the whole image? And you can see it happened 2 times. And also you can count all the other pairs and then create these coherence matrices. So because it's measured the neighboring correlation, so it's sensitive to patterns. Another way is just use the Fourier transform, and you can see that for the real image, there's no periodic pattern, but for the fake image, there's a periodic pattern, so it's effective. But like the most state-of-art GANs, they actually show less of these checkboard patterns. So like these are deepfake image detection. How do we deal with video detection? So to do with a video detection, basically we just add another dimension, the time dimension. So usually people use this convolutional LSTM. So in one timestamp, it's layers of convolutional layers. And in the time dimension, they use LSTM to do this detection. So yeah, it's pretty straightforward architecture design, and many people use that. It shows that it's relatively effective. I think nowadays people can use transformers. I didn't see them in literature, but I think transformer has a very good potential to actually perform better than these models. So there are much more things to do. Like I just introduced briefly about the literature, what people do in the literature. So deepfake and deepfake detection are like the relationship between computer virus and antivirus protections. So if we think about it, because if we want to train a detection model, we need the deepfake data because it's a binary classification problem, right? So we need a fake data. So we have to have the deepfake model first, and then generate a deepfake data set and train a deepfake detector. So that means for the detection system, it requires constantly update the deepfake detector by updating the rule of deepfake models. And also, people are trying to find a more effective kind of features, like the texture features, for detection. And here, I just show a few papers, not only just for image deepfake or video deepfake detection, but also some other deepfake detection. For example, this is for the voice deepfake detection, the deep sonar. It can detect the voice deepfake quite effectively. And there's image, GAN-generated image detection, and GAN-generated face manipulation, and also a localization of deep video in painting based on spatial temporal convolutional and refinement network. So trying to locate where the location in each frame of the video where it's being manipulated by deep learning techniques or deepfake. And also the big players like Microsoft also try to develop their tools, because deepfake is really pose a lot of stress in the social media. In the social media, it's usually some social media platforms, they have a very close group, and if you allow the fake information to spread in these small groups, it can affect people's opinions. Facebook work on the deepfake detection, and also Microsoft and Facebook work on the deepfake detection.